Welcome again. This question, we are going to solve residue of a function by use of the formula that residue of the function at the point z equals to a is given by 1 over n minus 1 factorial, n minus 1 derivative of the function, z minus a power n multiplied by the function f of z at the point z equals to a. So the equation we have to solve here is to find the residue of the function given by f of z, z squared over z plus 1 squared times z minus 2 at its double pole. So let's first find all the poles and then we concentrate on the double pole that has been specified. So solution, poles are given by taking the denominator, equating to 0 and solving. So i.e. z plus 1 squared z minus 2 equals to 0. So when you do this, we'll have z plus 1, z plus 1 times z minus 2 is equals to 0. So which means z equals to 1, z equals to negative 1, z equals to negative 1, and z equals to 2 are the poles where z equals to negative 1 is a pole of order 2, what we call the double pole, and z equals to 2 is a simple pole. So that's the first step. Now, because the equation specifies that we need to concentrate on the double pole, so our interest will be with z equals to negative 1. So the function f of z has a double pole at z equals to negative 1. So residue of f of z at z equals to negative 1 will be given by definition limit. So from this given formula, simply is not the limit, so simply the value of so 1 over, so n in this case is 2, so 2 minus 1 factorial, and then so 2 minus 1 is just 1, so let me just write 2 minus 1 is z 2 minus 1 into z, so minus 1 is plus 1, so n is 2, and then f of z, and then this should happen at z equals to negative 1. So i.e. this residue will be 1 over, so 2 minus 1 is just 1 factorial, then d dz of z plus 1 squared times f of z is z squared over z plus 1 squared multiplied by z minus 2. And then all these have to be evaluated at z equals to -1. So in this product, should be clear that this bracket and this bracket cancels out. So this will be 1 over 1 factorial just 1. So d dz of the function z squared equal to square, and then z minus 2, and we have to evaluate this at -1. So we use quotient tool to carry out this differentiation. So let this one to be u, this one to be v. So we know that the derivative is given by u prime v minus v prime u over v squared. So our u is z squared, our u prime will be 2z, our v is z minus 2, our v prime would be 1. So this will be u prime v, so 2z into z minus 2 minus v prime is 1 times u, which is z squared, z minus 2, and then you square. And then we carry out this at z equals to -1. So this would give us 2 times 1, 2 times -1. So I'm replacing where the z by -1, and then into -1 minus 2, -1 into -1 square. So the value of z squared here, divided by -1 minus 2 squared. So I'll have -2 times -3, this part, -1 times 1 when you square this, divided by -3 squared. So -2 times -3 is 6, -1 minus 3 squared is 9. So this is 5 over 9. So therefore the residue at the double pole for this particular function is given by 5 over 9. So that's the solution. Thank you.